Hello and welcome! If you follow my channel for a longer time, you will know that my videos are usually kind of a mixed bag. I know that every one of you has an own favorite type of the videos. The one is more into repair, the other is into DIY, upgrades or benchmarks. I'm not doing this primarily for clicks or whatever you would like to call it, but because of my own curiosity. The more diversified are the projects, the more fun do I have making them, and hopefully the more fun jumps over on you guys watching my videos. And today I would like to talk again about a DIY project which I made some time ago. I know that some of you are waiting for the continuation of the VRM project, and I assure you that I'm very excited about it too, but unfortunately there are some delivery problems and I still don't have everything to finalize the new prototype. That's why today's topic is going to be an update on another DIY project, which I'm actually very proud of. The GamePort to USB adapter, which you can use to connect a lot of good old GamePort joysticks, which are still waiting for their revival, somewhere in the boxes buried in the depths of your basements. If you didn't see the presentation video of this project, I highly suggest to take a look at that one first, because today I'm not going to explain again how it works. Instead, I would like to talk about what happened in the last months. As I said in that video where I revealed the project, I was not quite happy with the micro USB connector on the Arduino. It is only surface mounted on two spots, beside of the main contacts, and luckily it didn't happen to me yet, but I'm sure that the connector can be snapped off the PCB easily. So I was searching for alternative solution. Of course, you can solder additional wire on the edge for stabilization like I did here for another project, but that requires additional tinkering and I wanted to find a more universal solution. So I ordered such an Arduino with a mini USB connector. However, as I ordered it, I didn't pay attention that it is actually wider than the version with the micro USB connector. And since I thought that for the development it would be nice to have a reset button on the adapter, I designed a slightly bigger PCB with integrated reset button and where I could put the wider version of the Arduino with a mini USB connector too. Electrically, this version is identical to the previous one, which I open sourced. The pinout and everything else remained the same, so the very same software can be used with both of these adapters without any change. In the last months, I've been using this version of the adapter, but it turned out that the reset button was often not helpful, since I can reset only the Arduino itself using it, but not the joystick. The problem is that during the driver development for the digital joysticks like the Sidewinder, you need to reset the joystick as well whenever you reset the Arduino, but that can be only done by disconnecting the joystick from the power. That means that I would at least need an additional transistor and one or two resistors bound to the reset button to control the power to the joystick. So the design had to be refined once again. That's why I decided not to open source this revision as you see it here. However, the main reason why I was searching for a new design was still the fragile micro USB port, and I was really keen to improve that. Well, actually, as I was initially searching for an Arduino which I could use for this project, there were not two, but three versions of them. One with a micro USB, one with a mini USB which was more stable but also wider than the first one, and there was another one with the USB-C port which had almost identical dimensions to the one with the micro USB port. However, back then the USB-C version was harder to get and did cost 4 to 5 times as much as the other two. That's why I dropped the idea of using an Arduino with USB-C for the adapter back then. But the time has passed, the USB-C ports got more and more widespread, and today such a USB-C version of the Pro Micro costs only about 1.5 times of the other versions. But the most interesting detail about it can be seen on the back side of the Arduino. The USB-C version has a through-hole connector, which would solve the stability problems completely. Furthermore, the very handy thing about the USB-C type Arduino is that it is just as wide as the micro USB version, and so it can be used as a drop-in replacement directly in the released version of the adapter. No need to change anything whatsoever. One minor issue is that the USB-C type Arduino is slightly longer, and so it stands out of the whole construct by a couple of millimeters. I think it's not critical, but would be a problem if you want to make a universal enclosure. Theoretically, the adapter can be made slightly longer to be in line with the USB-C type of the Arduino, but then it would be too long for the micro USB version. So for now it remains as is, and dependent on what you can get in your region, you can use the one or another. Now let's talk about what happened in the software, since the most work has been done there. And I'm glad to announce that since my last presentation of this adapter, the list of supported joysticks grew quite a lot. Last time I said that it supports all the analog joysticks, gamepads, steering wheels and so on, but also digital Sidewinder 3D Pro joystick with all 8 buttons, 4 axes and a directional head, as well as Sidewinder gamepad with 10 buttons. This was already more than any other well-known adapter like this Rockfire, for example, supports, since such adapters are all usually limited to the analog joysticks only. Well, I'm glad to say that since the last time the software was heavily refactored, the USB code was completely re-implemented and unified, so adding new devices is now a lot easier. And so many new supported devices were added to the list, either implemented by myself or contributed by other people. Besides Sidewinder 3D Pro and Sidewinder Gamepad, which I mentioned last time, this adapter supports now also further members of Sidewinder device family, the 3D Pro Plus, which is also known as Precision Pro 1, as well as Precision Pro 2 and Force Feedback Wheel. Unfortunately, the force feedback functionality itself was not yet implemented, but I will spend some words on this topic a bit later. Furthermore, now the implementation is not limited to the Sidewinder product line only. Other digital protocols were implemented for the Gravis Gamepad Pro, as well as the ADI joystick protocol, which was used by all the digital Logitech input devices like the Wingman Extreme Digital or the mind-blowing Cyberman 2. Other Logitech devices were not tested yet due to the lack of such, but most of them should work as well. This is the most versatile GamePort to USB adapter you can get today. It is completely open source and the software is very easy to extend with support for even more GamePort devices. There is absolutely no reasons anymore to throw them away, since now they can be easily used in any modern operating system such as Linux, Windows or Mac OS. It is even possible to use it with Android on a smartphone. You just have to connect the joystick to the GamePort adapter and the USB cable into the phone. I have no USB-C port on my smartphone, that's why I use an additional USB to micro USB adapter. But if you have a smartphone with an USB-C port, you can simply connect the GamePort adapter directly to the phone. Anyway, the main thing is that the joystick works on an Android, as you can see. If you can use it in the games, well, it's another question. Unfortunately, the standard Android has a very limited support for the joysticks, gamepads and similar human interface devices. And I also don't have any games on my smartphone, so I cannot currently show you anything except of this Gamepad Tester app. But the point is that this GamePort adapter works even with Android, at least to some extent. However, the main aim of this adapter is to provide a GamePort interface for a modern desktop PC, to be able to play the old and modern games with an old good joystick, gamepad, or even with such an alien technology Logitech Cyberman 2. One question which I already got many times was about the latency, and as I said the first time as I presented this project, the latency is extremely short, and I paid a lot of attention to keep it as short as possible. Depending on the protocol and the type of the joystick, the delay is somewhere between 1/2 and 5 milliseconds. In other words, you barely can feel it. And just to show that it is good enough even for the really fast games, I would like to present to you one of my favorite racing games of all times. Star Wars Racer. This game is about 20 years old, and to be honest, you will run into some issues trying to run it on a modern PC. And I even recorded this on Linux, so there are some minor visual issues like the small video size during the cutscenes, but it has no impact on the gameplay itself. Unfortunately, I had to turn off the music to avoid any problems with YouTube. That's why you're gonna hear only the sound effects. This game supports joysticks, and I am going to use the Logitech Wingman Extreme Digital. A very nice joystick, quite heavy, very stable, with 6 buttons, 3 axes and a head switch. This joystick is super easy to set up in this game. Simply use the default settings and you are good to go. Regardless if you are going to use a joystick through the GamePort adapter or directly a modern USB joystick, believe me, once you play this game with a good joystick, you will never want to play it with a keyboard again. Especially with the throttle axis and additional buttons for repair, slide and tilt, this makes really a lot of fun, and 20 years later I still love this game. Now let's talk about one of the most common questions. Where to get this adapter from? Previously I said that I was thinking about to open an online shop for all the DIYs which I am making. Well, unfortunately it turned out that in Germany it is nearly impossible to do it officially for multiple reasons. The most important one is money. It is simply too expensive. That's why I had to bury this idea for now. So I'm afraid the only one way to get such an adapter is to build it yourself or to ask somebody who would be able to build it for you. The Gerber files for the PCB can be found in the release area of the project site. Simply take the Gerber zip file and upload it to your favorite PCB manufacturer. Plenty of the other retro hardware channels make a lot of commercial for such manufacturers. You probably know what I mean. You can find the bill of materials on the project site as well. It even includes the part numbers of some known stores. Once you have the PCB and the parts, the soldering is really trivial, and with some experience it can be made in 5 minutes. And here is one advice how to solder the Arduino. It might be helpful not only for this project. The Arduinos are usually delivered with such pin headers, which have to be soldered manually if needed. Well, the pin headers are slightly longer on the one side and shorter on the other. In the most cases, you would solder the pin headers with the shorter side through the PCB, leaving the longer pins outside. This way it is more comfortable to use an Arduino, for example, in a breadboard. However, when using an Arduino in this adapter, it is very handy to turn the pin headers around and solder the longer side of the pin headers to the PCB. The shorter side is still long enough to be inserted into the socket, like so, or to be soldered directly to the PCB without a socket altogether. Why is it handy to solder it this way around, you may ask? Well, if you develop your firmware, it is often very useful to be able to connect such a logic analyzer to the pins of the Arduino to be able to sniff the signals, for example, for debugging or joystick protocol analysis. This is, by the way, how I developed this device. I used a logic analyzer all the time to measure and tweak timings, debugging and so on. Now when you have these longer pins coming out of the PCB, it is a lot easier to connect the clips of the logic analyzer and keep them reliably in place. And as I said, the socket is actually optional. It is better to have it if you want to swap the Arduinos for some reason, like I did with the USB-C and the micro USB version, but if you think that you will not swap it anyway, you can even leave the socket out, save a couple of cents and make the whole construct even more rigid. However, I cannot say that with the socket it would be unstable, since the Arduino is sitting really tightly. Two additional things I would like to say about the current state. First of all, I already mentioned the Microsoft Force Feedback wheel, for which the support was contributed by a user Ehud Katz. Thank you very much for the implementation. That was very well made and the wheel can now be used as an input device. However, the force feedback feature itself is unfortunately not yet implemented. I don't have such a wheel, but if someone of you out there has one and wants to try to implement the force feedback feature, you are very welcome. If my information is right, the force feedback is controlled by the MIDI in and out pins of the GamePort, and those are already wired in the GamePort adapter to the Arduino. Those pins were simply not yet used, but hopefully this will change in the future. Second thing is that I regularly get a question about the Gravis Phoenix joystick support, and I have to admit that to be able to support that one it will need some more work. The problem is that the Gravis Phoenix uses, besides of the GamePort, also the keyboard pass-through for communication with the PC. In other words, Gravis Phoenix is half a joystick, half a keyboard, and so the adapter needs to be equipped with a keyboard's DIN connector, and the software has to implement some kind of keyboard protocol. This might happen in the future, but currently I have no plans to make it anytime soon. So, and this is actually all the updates I wanted to bring up. As I already said, a lot more joysticks are now supported by this adapter, and I hope for even more in the future. As I said, this adapter is already more versatile than any other GamePort to USB adapter you can find. At this point, I would also like to thank all the contributors and testers. This project relies on every feedback and implementation it can get, since I just don't have every possible joystick at hand. So, if you want to make this part even more universal, consider to provide an implementation for the devices you possess. And for the ones of you who watched this video up to this point, first of all, thank you very much. My channel experienced quite a huge increase of subscribers in the last 3 months. And as I am doing this video, the number is already approaching incredible 20,000 subscribers. I'm very happy to see that so many people like what I'm doing. I'm not only very grateful for all the support via Patreon and PayPal, as well as exciting hardware donations, but also for all of your kind comments, likes and constructive critics. Even a simple thank you often makes my day and gives me the power to make another video. And today I would like to thank you back and give you an opportunity to win one of these 2 GamePort adapters. But to make it a little bit interesting, I decided to make a small quiz. In this video I have shown you this Logitech Wingman Extreme Digital joystick as I played Star Wars Racer with it. And for this joystick, the switches must be set according to the documentation on the project site to 1001. Which stands for on, off, off, on. In my last video about this GamePort adapter, I was playing Wing Commander Prophecy with another joystick. So, if you want to win one adapter, please write into the comments which joystick it was and how the switches have to be set on the adapter for that model. Attention! It is important to use the same 0 and 1 notation as it is used in the documentation, because I will filter the comments and pick 2 random winners from the list. You can find the link to the mentioned video and to the project site in the description. I never did this before, so I have to find out yet how to notify the winners, but I think that I will publish a notification in the community tab or maybe make a short video, so keep an eye open. And this is it for today. I hope you like how this small device developed so far. Feel free to build your own adapters, share the project with your friends and help me to extend the support for other joysticks and gamepads. And for now I say thank you and goodbye.